So,
OpenVZ.
Yes, it's time to start. Hi everyone, my name is Kolyshkin. This is my second time in LinuxFest Northwest. I came here in 2013. I was talking about Crew and OpenVZ, and this time I'm talking about OpenVZ and Virtuozzo and Docker. So this is the title. The agenda here is pretty simple. First of all, I will go through the history of containers for the last 15 years, and as a mostly the history of OpenVZ, but I also added some other events to the timeline. And then I'll talk a bit about how we are trying to relaunch Virtuozzo. Virtuozzo is a name used for commercial version of OpenVZ, and then we changed that name. Now we're sort of going back to our roots, and we try to call everything Virtuozzo. And OpenVZ is, of course, VZ from Virtuozzo. So, and there's one important announcement that I would like to make. Finally, I'll talk about how we play with Docker inside, outside, and outside of OpenVZ. So, history. It all started in 1999. It was a chief scientist at our company. He was also an MIT professor. Proposed the idea of having those lightweight virtual environments as groups of processes running on top of the same server, with the three main components being those groups of process with namespace isolation, so groups don't see each other. Then the common file system to make it possible to share the code and therefore save RAM and make density higher. And finally, some resource isolation management mechanism to keep those groups within the limits. He was given sort of the green light to go on with implementation, and in 2000 there were 3 engineers started working on it in MIT. MIT is Moscow Institute of Physics and Technology in Moscow, Russia. It's sort of the local analog would be MIT, I guess. So there were actually 5 people, sysadmin and the manager / engineer, plus 3 engineers, and they tried to create a first version, build some sort of a mock-up. And then later they hired a guy to write some web management for it. And as soon as in July 2000, they actually did some public beta testing, put 2 servers on the internet. One was for those containers, and the other was for that web management thing. And they had around, by the end of the summer, they had around 5,000 containers on that servers. At the time, they were called virtual environments. So the term containers coming later. And during that beta testing, they found out how easy it is for Linux processes to use and abuse resources, like eat all the RAM or just trash all the CPU and so on. So they ended up hiring a mathematician guy from Moscow State University, and Moscow State University is more like Stanford if you want a local analogy. And he was started working on the resource management. The project was called user bean counters, and there were actually another guy trying to do something like that, and that other guy was Alan Cox. And so they started working together on the user bean counters patch in order to implement group-based resource management. So So the thing is, in Linux, the traditional, in any Unix, traditional way to limit resources is ulimit, but it's a per process thing. And in here we have groups of processes. And in general, in modern work, we have groups of processes, like a web server or a database server is a group of processes. So ulimit doesn't really apply here. Thus the need for stuff like user bean counters. Oh, and modern name for that is secrets. And they had some success with that, and they keep on developing it. And based on success of Virtuozzo, they started a different project, Virtuozzo for Windows. If you ask me, it's a pretty crazy idea to implement the same stuff for Windows because of the lack of sources, mostly. And that required a lot of reverse engineering and, you know, finding the way to live patch the kernel and so on. And the major idea there that in Windows everything is an object, so all those objects need to be virtualized, or namespace in other terms. And I was not able to find the source for this quote, but someone from Microsoft said that Virtuozzo for Windows is most advanced piece of software ever written for Windows, and it probably is most complicated thing. I'm a Linux guy. I don't know much about Virtuozzo for Windows, but what I know is they reverse engineer everything, they live patch everything. They had to disable software, the Windows kernel software written specifically to prevent patching the kernel, which is called patchguard. They had to so it's sort of you can see it as sort of the very advanced virus that patches the kernel. And also in 2001, another containers project appeared. It's called LinuxFest server. I think that guy is still there. Later on, we tried to work with them together, but haven't found any common ground. So they don't really want to contribute their changes back to upstream, so they're totally separate patch. 2002, those guys working in MIPT went on to the first Virtuozzo for Windows release, which was called 2.0. I'm not sure why. And we got first commercial customers. I wasn't connected to that project at that time. So it went on and on. I haven't really able to find any items for 2003, but I remember I was sitting next to the guys basically in the same office, and they were developing, hiring more guys for the project. And here comes 2004, then the Solaris zones appeared, and it still lives nowadays in form of Illumos project, but I think the biggest contribution is the term container, because we were calling it Linux vServer guys called it vServer. We called it virtual environment. Later we called it virtual private server. But I still think the container term is the best, and thanks to something like that. And also in December of 2004 we released first Virtuozzo for Windows. In 2005 we realized that we better be open, and we gave birth to OpenVZ project, which is sort of the open source core of that Virtuozzo thing. So this is how OpenVZ project was born, and the main ideas were that we do want to merge most of our in-kernel modifications to the vanilla kernel upstream, send the stuff to Linux and guys. And another target was basically to educate people about containers, to let them know that such lightweight virtualization exists, and in many cases it's better to use it rather than full-scale VMs because of the better density, high scalability, and better performance, and so on. And with OpenVZ we had many interesting years. So in 2006 we did quite a lot of things. 42 kernels, various kernels, including 2.6.15, Dual Core 5, just to show that maybe some distros might use our kernel. Then Debian included that. So at that time, Debian included many different kernels, like separate Zen kernel, separate Linux server kernel, separate RT kernel, and they also included OpenVZ kernel. And they later dropped it because they found that it's pretty complicated to manage a lot of various kernels, and their team is just not have enough resources for that. Then we rebased to the HEL 4 kernel, which was a pretty interesting point because we found out that we are sort of creating our own distribution, and because of that, we have a lot of maintenance burden, updating the drivers, fixing security bugs in the kernel, and so on. I mean, of course, if you run hundreds of containers on top of the single kernel, this kernel has to be rock solid. And so we ended up with, let's say, this amount of patches implemented container functionality, and this amount of patches implementing driver updates and security fixes and some other stuff. So we rebased to HEL 4 Red Hat Enterprise Linux version 4 kernel. And since that time, we've had a pretty good experience with that. So by basing off this kernel, we let Red Hat guys do most of the work on the driver updates, security patches, and stability. And we concentrate better on our staff. We also did some initial testing for trying to port this thing to Spark and PowerPC, and it all went pretty well, but later it went nowhere because of no users. We also released live migration capability for OpenVZ during that year. But live migration, of course, makes it possible to take a container with running applications and move it to a different physical server without stopping it, without shutting it down. So it's just another degree of freedom and helpful in a few scenarios. So 07, some commercial Unix vendors implemented their own containers. So in IBM AX6, they implemented so-called WPARs, workload partitions. These are basically containers. And HP UX, I'm not sure which release is that, 12, 13 maybe, they implemented so-called SRP that are also containers. At that time, we have rebased to the next kernel, Red Hat Enterprise Linux 5. Also did an experimental port to 2.6.20 kernel and released some live CD. One was Novix based, another was CentOS based. 08 was very good, fruitful year as in terms of our contributions to the mainline kernel. So I remember we had a few engineers working exclusively on trying to merge our stuff upstream for many months, and it all went pretty well. The biggest, most complicated thing that went upstream was network namespace. Basically, what network namespace is, you have Linux kernel, inside it you have network devices like Ethernet device, loopback device, some, I don't know, tunnels, bridges, and all that. They have routing tables, we have ARP tables, we have firewall rules, table rules, and so on. All of this is networking. So, but with network namespace, it became possible to create multiple instances of that networking, with each namespace having its own network adapters, routing rules, blah, blah, blah. So basically, our containers, they each have separate networking space. The other thing we managed to merge to vanilla Linux is process ID namespace, which is basically a way for a group of processes to hide itself from anyone else. So each container is just a group of processes, but they shouldn't see each other. Therefore, feed namespace is required. And the other reason why it is required is that the init process is supposed to have a feed of 1. And so in every container we have that feed of 1. IPC namespace is for sysv, shared memory, semaphores, and stuff. And there are also other minor namespaces. Also, 08 is when the LXC project appears. So there is a big misconception about what LXC is. Most of the people that I met think that LXC are Linux containers. It is Linux containers, but essentially this is just a user space tool implementing the functionality of containers. And the kernel part is separate, it's not LXC. LXC is just user space tool similar to what we have, which we call VZCTL. Speaking about upstream kernel, it's not just us who managed to merge some containers functionality. Other parties were also interested. I should definitely name IBM, Google, and one contributor who was very prolific was Eric Biederman, who did a lot of namespace work. But our contribution was, I think, about half of all the container stuff in the upstream kernel. In April, we did the port to 2.6.25. We did port to ARM, also experimental, so it basically went nowhere. And because of all that work, in 2009, we were listed in top 10 Linux kernel contributors. And we were listed there a few times later, just because of that thing, like next to big guys like Red Hat and IBM, and we're a pretty small company. The amount of kernel engineers is different times. It was, let's say, from 5 to 15. In 2010, we did a port to Health 6, and with their Health 6 kernel, we introduced two very major improvements. One is called vSwap. It's basically a way to have very simple container limits. Instead of, so that user bin counters I mentioned earlier had about 20 different limits that you need to set, and they're interdependent and they're pretty complex, and you had to read about each and every of them. What does it mean, how it should be used? Pretty cryptic thing, and you really need to read a book if you want to be able to manage user bin counters. And with vSwap, you only need to set two parameters for a container, rem and swap. Doesn't need any explanation. You don't have to read a book. And the other improvement was PLOOP, also known as a container file system in a file. Basically, it's similar to a way that VMs work. They had a big file on the host, and inside that big file, they created some hard drive and file system and all that. We created something similar, but a bit more lightweight, to be used by containers. And the reason for it was we found out that common file system, if few containers share the common file system, and it's usually ext4, for example, or other file system like that, most of them have journal. The journal, common journal, the file system journal is a bottleneck. Every container can make a series of small operations involving file system metadata, such as you have a 1 megabyte file, and then you truncate it by 1 byte. And you can easily have 1 million requests. And every file truncation is a file metadata operation, and it requires to go through the journal, and the journal is of limited size. So it's very easy to separate the journal. And while you're doing the truncation, everybody else have to wait. So we figured out that every container needs its own separate file system, and for that we created that loop thing, which is basically same as a loop device, but with some extra bells and whistles, such as on-demand allocation. You don't have to allocate all the disk space in advance. It grows on demand. We implemented instant snapshots. We implemented online resize in both ways, online merge of those snapshots, online compacting. And finally, we implemented write tracker to aid in live migration. That is a mechanism to basically keep tracking of which blocks of data were modified, so we can copy over only the modified data when we live migrating container from one system to another. Each of those features probably requires separate full size 45-minute talk, so I'm trying to be quick here. In July, one of our developers sent an initial proposal for CREW. CREW is checkpoint restore in user space. Basically, when we opened OpenVZ in 2005, and we had a goal to merge our stuff upstream, we tried to merge bits and pieces of it. We succeeded in merging most of the namespaces and some C group controllers, but with checkpoint and restore thing, we failed miserably. So what is checkpoint restore? It's a way to get a group of running processes and dump them on disk, to the disk, freeze them and dump them to the disk. Pretty much as suspend to disk works, then you shut off your laptop, but not for the whole system, just for the group of processes. And later, using the dump file, you can recreate all the running processes back, like they were running before. And if you do it fast enough, TCP connections stay alive and so on. And it's a pretty complex thing, and it was implemented in OpenVZ kernel, and we tried to merge this functionality upstream, and we failed. And then there were other guys who were trying to do the same, such as Odin, trying to merge his checkpoint restore kernel thing. And it didn't work because such feature, it touches each and every kernel subsystem. It's like, it basically, it's everywhere. Like fork, you need to modify it. Everything, and no kernel maintainer wanted that crap in their code. So the idea of CREW is to try to do it from user space. Was another crazy idea, if you ask me. And I said it's not going to work. So most of the data is available from /proc. So you can go to /proc/bit something and read the open file descriptors, mappings, parent-child relationships, and so on. but some stuff is missing, and the idea was take most of the info from proc, what is missing, patch the kernel to provide that information. And checkpoint is basically, we read everything from proc and we create a dump file. Of course, we also need to freeze the process, maybe kill them. Restore is a bit more complicated, but in a nutshell, it's read those dump files, recreate an environment, like if there were open file, reopen that file with the same file descriptor, position it, and so on. It's a bit more complicated than that. It requires some pretty complex things, such as we have a parasite code injected into the process which is about to be dumped. And because some information about the process, we can only obtain it from the process itself. So we have to become that process in order to obtain that information. So using the debugging mechanisms, we inject our parasite code into that process being dumped, and we get some information from there. Restore is a bit complicated as well. But that time, it was a crazy idea. Nowadays, it's working. So, 012, we had an initial crew release, version 0.1. And later in October that year, we released VZCTL, which VZCTL is our control tool. It's like LXC tool. That VZCTL started to support vanilla kernel, 3.x kernel. So previously we required our stuff to have OpenVZ kernel, and since that release, it is possible to use our user space tools with vanilla kernel. Not as good as with OpenVZ kernel, but still. And sometime that year, we started working on rebasing on RHEL 7, the next release of the RHEL-based kernel. We're getting closer to now. This year gave a lot of birth to projects like Docker, LMCD5, which stands for Let Me Contain That For You. That's a project from Google, which we use internally. Core OS, all three of those, as well as LXC, are using kernel mechanisms that we have added earlier, like those namespaces and stuff. In the meantime, we added I/O and IOPS limits to VZCTL and the kernel. In May, we announced so-called OpenVZ maintenance partnership, where we have paid support, because previously we didn't have any of that. Next year, we did some more work on the user space, faster live migration, improved pilot migration. And finally, in December, we announced merging of OpenVZ and Parallels Cloud Server. Parallels Cloud Server was another name for Virtuozzo at the time, into a single common open source database. The analysis at that URL. I did it back in December, and I had a lot of questions of what are we trying to do here. So basically, we tried to sort of reboot OpenVZ. And this is why. We have a couple of problems nowadays. One problem is our kernel development is not quite open. I would say it's throw it over the wall style open. So we write the code and make releases. And you can get source RPM and you can get the patches from there. That's it. Our devel list is desert land. We don't even have the Git repo. Not because we don't want to show the code, but because our internal process can't be laid into Git. It's a set of patches that we manage and so on. So this is the problem with the kernel development. And the problem with the user space development is when we opened OpenVZ in 05, our tools have diverged. So we have the commercial tools in the commercial version, and we have open source tool in the open source version. And they were pretty much the same at the very beginning. But somehow, somewhere, it went to situation that nowadays our development effort is doubled. We have to develop same features for both projects separately. And I think I'm the guy who suffers most from this. The other problem is we have OpenVZ is open source, free, no strings attached. But we also have the commercial product on which we make money. And the current situation is, if someone tried OpenVZ and liked it so much that they wanted to pay us money, they have to upgrade to the commercial stuff. And there is no easy upgrade path. You have to reinstall it from scratch because of the differences in tools. It's a big problem. And it's a problem for people who want to pay us money, so we take it seriously. Due to that user space for some features are missing. So for example, our package management, VZ package that used to be there for OpenVZ is gone. Because I just didn't have enough resources to maintain it. And finally, that creates unnecessary complications for our QA, for our support, because we basically have two different code bases. And this is what we're trying to fix now. We're trying to bring in something that is called Virtuozzo or OpenVZ or call it whatever, but the thing is it's a unified code base and truly open source development process. We made a mistake and we try to fix it now, better late than never. So now we will try to really do the development in open source model. I mean, it's gonna be tough because from what I see, only the projects that they're truly open source from the very beginning can stay that way. And if you're introducing something that was previously not very open source, it's gonna be very, very complicated. But we'll try. So we'll do discussions, our developers will discuss on the public mailing list, so you can interfere and add your voice. We'll open the source code repository for the kernel, and we'll have more ways for the community to contribute back. And it's a unified code base. And other thing about Virtuozzo, it's going to be bare metal distro. Because we found out that if we install on different distros, they all have different tools, and we sometimes have problems with that. And we'd be better off with our own distro, which is basically yet another clone of CentOS, of Helm. And we'll have the VM support in form of KVM, but it's coming later. It will not be anything initial data. And this is the announce. So right here, right now, today, we are opening our Git repository with their Helm 7 kernel. It is available now from this URL, source openvz.org. You can see that we've been working on that kernel for about 2 years, and the only reason we are opening it only now because it's pretty complicated inside the company to move the process from being all closed source in the root to the open. It took a lot of time to do that, to make people use Git, to reformat all of our internal mechanisms to be able to use it and so on. So this site is still embedded, but you can register, and we'll also open up the new bug tracking, which is based on Jira, and both source repo and bug tracking will be integrated. And a few things about the kernel, which we are opening, is for Health 7-based kernel, which everyone was waiting for. It is currently very, very beta quality. Good things though is it uses Creo for migration. So that project that we started, a lot of people are already benefiting from it. Now it's time for us to benefit from it as well. So we basically discard our own in-kernel checkpoint restore code and replacing it with Creo. Also, some of the APIs to manage containers has changed in the kernel, and current VZCTL is not yet working with them. So good and bad things about this. And this is just the first step. It's actually the first step since, I mean, something real that we can show now. Since December, then we announced that we go this way. And in the nearest future, we're going to publish the tools, a lot of tools, much more than currently available in OpenVZ. Establish all the process, release beta, and so on. And we hope it will all went well. I wanted to talk about Docker, right? So, basically we enabled projects like Docker, as I said earlier, by having this functionality in the kernel. And because of that, we think Docker is sort of like our child, so we love it. And we support it everywhere. There are three things about Docker which I wanted to touch base. First of all, we make Docker running inside our container. So you can use existing OpenVZ and run Docker inside OpenVZ containers. Second thing is we are working on making Docker use our containers as Docker containers. So it's not a nested model like in it's just that we believe our kernel is a bit better in terms of resource management and isolation, is a bit more secure, is a bit more manageable. So we modified Docker to be able to use OpenVZ kernel in addition to the upstream kernel. And also we made possible to live migrate Docker instances with the help of Creo. So let me cover all three cases. Basically, this functionality is available in it's not something very new. So you can use it if you have pretty recent OpenVZ kernel and user space. It's the how-to is available at openvz.org/docker inside CT. And the current limitations are we don't do checkpointing and live migration of the Docker-enabled container. That's a big limitation for people who rely on live migration in their setups. But some other people who don't use live migration, they just don't care. Currently, the only graph driver that is available in Docker is VFS. We don't support any other, but we are working on that. And I'm not sure if it's a major showstopper, probably not, but if you use Docker containers inside OpenVZ containers, inside those Docker containers, you can't create bridges. So let me give you a few pieces of information about what we do to the kernel to make it able to run Docker inside container. Basically, both Docker and OpenVZ uses the same mechanisms, namespaces and stuff. So we made our kernel to be able to have nested namespaces that include network namespace, IPC, UTC, and other namespaces. And we have to allow some things and disallow something inside those namespaces. So, for example, VNet device is used by OpenVZ, so it doesn't make sense to have it inside Docker containers or inside OpenVZ containers. And there were some sysfs and capabilities hacks, and we brought in false CPU sets and C groups in order for Docker to manage those. And there are a lot of fixes. Actually, I wanted to do a live demo. I'm not sure if I have time for that. But let me try to start here. So blind typing, huh? Okay. Where am I? So this is what I'm using to create a container which is able to run Docker. Basically, we create a CentOS container with some big disk space. We set a few parameters so the Docker can feel at home. Like we enable bridges, we enable full IP tables functionality, add a tune device, and an IP address, and we do some hack for CPU sets and C group. So this is how we create. I just ran that script. So now we can install Docker because it's not there by default. And we are inside a container now. We just installed Docker. So, we have to run Docker daemon first. So this is the Docker daemon, and here we can actually try to create and start Docker instance. So this command will download lots of stuff from the internet, so I'll return to my presentation and we'll continue later. story repeating itself. Right. So all this stuff is working, and I hope I'll give you a live demo when this thing will download. The other thing we're working on, this is sort of totally unrelated, is we're trying to enable for Docker to use OpenVZ kernel instead of relying on upstream functionality, relying on OpenVZ functionality to create Docker containers. I would say OpenVZ enhanced Docker containers, something like that. For the reasons I explained earlier, like we think that we do better resource management and some other stuff. So basically, for that thing, we have implemented a library called libct. So Docker relies on a library called libcontainer for interfacing with the kernel. And we have created some smaller library called libct, which can be called by bigger libcontainer library. And that libct supports our API. And this thing is about to be included. So initially, the pull request for inclusion was opened a month ago, and there's a big discussion over there, a few iterations of patches going on. I'm not sure when, but it's about to be included. You can get it from this pull request 434 from the container. And so this is the current status of the task. So you can use Docker on top of OpenVZ kernel after this thing will be merged. And in the meantime, we found one interesting thing that I wanted to share with you, that a libcontainer is written in Go, and our libct is written in C. And we found out that sometimes libct works a few times faster. There's a pretty big gap. We think it's about the heap management in Go, which is not yet sorted out. And the third Docker-related project is the checkpointing. So with Creo, we have an ambitious goal to checkpoint everyone everywhere, and of course be able to restore them. And since Creo 1.3 release, which was last September, so-called external checkpoint restore of Docker works. Why we call it external? Because Docker doesn't know anything about it. We just take the Docker container and checkpoint it. Unfortunately, once we do that, Docker thinks that this container died. So when we later restore it, it is no longer able to see, because it appears from nowhere. And those commands like ps stop keylogs, they don't work anymore after checkpoint and restore. So this was more like a proof of concept that we are able to correctly checkpoint and restore everything that Docker sets. And the solution to the problem of Docker not seeing the restored container is, of course, implement a checkpoint restore right there in Docker. So Docker drives it, Docker is aware about it. Currently, there's a guy from Google, Saeed Kazemi, who's working on that mostly. And in his GitHub repo, you can see the wiki with the current state of the project. But basically, we have just released Creo 1.5.1 with some extra fixes for this functionality with Docker. I don't know when this will be merged, but with the support from Sayed, it is working. So basically, the idea is you can run Docker checkpoint, and your container will be put on disk, frozen, put on disk, and then you run Docker restore, and it keeps running. A few use cases for that are, of course, live migration, so you can checkpoint it here and restore it there. if you do it fast enough, all the TCP connections remain intact. Also, you can do things like if you want to restart the Docker daemon, for example, to upgrade. Now you can do it without losing all the containers, without needing to stop all the containers. Same thing, you can reboot the host without losing all the containers. With CRIU, you can do some sort of forensic debugging. Basically, if you checkpoint the container, you have lots of image files, and in those image files, you have the state of the process. Sort of like core file to be used by GDB, but a bit more information than you can restore from that. And we are doing in CRIU project, we're doing some tools in order to do those debugging. And then there is a demo of Docker checkpoint restore, which Said did. It's available from YouTube. So let me go back and see. Complete. So this is, we just run the MySQL container. And in addition to that, I want to run a WordPress container, which is connected to the MySQL one. Unfortunately, this stuff will run a bit more data, but I have another container which is already passed through this, so I can show you that one. I'm not sure. Maybe we should wait for this one to finish. So what else is there? I just want to give a few words about our future projects. Sort of a sneak peek. I don't know how to make it return to the You memorized all this already.
You need a checkpoint restore for your presentation.
Yep. So, just a few words about future direction. So, of course, our goal number one is to deliver a new OpenVZ and Virtuozzo 7, which will, I said no ETAs, but I think it will take at least another year for us to finish all this stuff. Another interesting project we're trying to work is the fourth generation resource management. So we had user bean counters when we had vswap, then we had cgroups, and now we're trying to make it even better. Resource management is a big thing in OpenVZ, and it's pretty complex. Like, you have various containers, they all start from resources, they all share the resources of the same machine, and there are many various scenarios in which they can all go wrong. And of course, user interface to that should be very simple, straightforward, and allow some flexibility. So what we're trying to do is we're trying to add another user space daemon which will watch those containers, eating RAM and using other resources, and trying to tune those resources in the runtime. It's going to be complicated because previously we tried making something like this. It was called SLM, and it was now I can tell it was a bad idea, but it took us a few years to realize that. It was an in-kernel mechanism that tries to figure out, like, this is SSHD, we shouldn't kill it. And this is a patch, we can probably kill some children. And this is MySQL. We don't really want to kill them because the database will be lost. And it tries to dynamically tune all the limits and resources. And this was done in the kernel. And it was not a work because maybe there were too many different heuristics. Maybe because it was in the kernel. But nowadays, due to crew success, we want to implement this daemon in the user space. Maybe using some mechanism to talk to the kernel, but it will be in the user space. And it will allow things like bursts, like if container wants twice the amount of memory that is given, we can give it to the container, but not for too long. Maybe someone is doing something for a few seconds. Why not? And when we tie it back, we will also try to implement guarantees, which are much more complicated with Linux. And here we speak from our 15 years of experience working with that. Another project is port to PowerPC. I said we already did that once, but this time is more real. Maybe we'll have some real users of that. And maybe ARM, because they always tell that all the server farms will be on ARM. Maybe it will happen, so we don't want to miss the train.
Doesn't CRIU already work on it?
Oh?
CRIU already works on
Oh, yeah, they do have ARM port, that's right, and they support ARM64 as well. And one other project which has a pretty stupid name, MetaPC, which is basically a single system image project based on CRU. Basically, the idea of that is that a few servers share the same, it's like host to containers. Like the containers, we separate the servers into small containers, and with MetaPC we combine many servers into one single thing. And the implementation that we're currently thinking about is going to be used based on CRU. Like instead of the processes running, we create some sort of a proxy process, which if you write to the pipe of that process, it will forward the pipe to a real process, which is on a different machine. So each process will be able to do IPC stuff, but they will be on different machines, but they will act like as they're on a single machine. It's very research stage at the moment, so I can't really tell you much. Oh, what's up with the daemon? What? No such.
This is how we know it's real, though.
Oh, I thought about it. Is it networking? You know, those demos, they always go wrong. But I swear it's working. Anyway, I can't be able to show this slide. For the last one, I'll just do this. No. So, we are on Twitter, Google+, Facebook, and we have a standalone blogs, and all the other means of contacts are at openvz.org/contact. And if you have any questions, I think we have some time, right? Yep.
Yeah, I was just going to ask you a little bit about the resource management thing. So, have you guys started thinking about some specific APIs that you, I mean, you're talking about a user space daemon. I'm not sure what advantages that would have to doing similar heuristics.
It's basically the idea to put it in user space. It's a twofold idea. First, we already have pretty good mechanisms in the kernel for the limits and for sharing and for paging out when it's then resources are called to the limit. But and we don't really want to touch that. It works pretty good for us. What we want to introduce is another dimension, the dimension of time, and we don't want to clutter the kernel with that. This is why we're trying to do it in user space. And the other idea is we're probably going to have some heuristics about this. And we want to be able to manage those heuristics and maybe to change them as frequently as we can. And we don't want to recompile the kernel for that. So this is why it's going to be user space daemon, which will use existing mechanisms, be C groups or bin counters, probably C groups. We'll probably just introduce some, I don't know, statistics model into the kernel if it can't be implemented in user space or if it's very slow in user space. But this is the main idea of that. And I actually heard, I think it was like 10 years ago, we talked to some of the big Linux vServer users, and they say that they are not happy with the current resource management thing in Linux vServer, so implement user daemon on top of that. But in that case, it was more like, let's kill the abandoned container or something like that. And in our case, it's more like tuning those limits and figure out the whole state of the system.
Yeah, there's a sort of, the reason I ask this is sort of a similar problem in energy efficiency, so which we spent a lot of time thinking about for Solaris recently, before the end. One of the things we were starting to think about was, having actually the apps that try to advise the system of their resource requirements. Because one of the things you want to do for energy efficiency is kind of shrink to fit, right? So you depower a bunch of stuff or put stuff in lower C states or C states. And you want to anticipate resource demand that's coming. And so sometimes the apps themselves can know that. Or the other thing you can do is, so it's possible that you might sort of introduce some specific APIs where apps would advise the system.
Currently, I'm only aware of the POSIX semi-advice system call, which tells about the memory, like I will need it only once, I won't need it, I will need it. This is the only mechanism I'm aware of.
Yeah, we never actually implemented this. It's just stuff we just started thinking about before we got to that.
And we're trying to figure out the similar mechanisms for crew, for example, to tell application that it's about to be checkpointed. So maybe it will drop the caches and the checkpointed image will be smaller, something like that.
Yeah, another thing you can consider doing is, and this is again just an idea as opposed to something we implemented, but I had considered kind of keeping track of resource usage of various apps from runs, and so you kind of keep keep that metadata around, and sometimes you get a high degree of repeatability in behaviors of apps if they're consistent things. I mean, sometimes you don't, but you can actually have this sort of sort of metadata on the side that you can use to sort of inform, sort of predict what what you might get certain resource spikes.
So this is what we're trying to do, is that time dimension. Like, see, this container was acting good, and now it's acting bad.
Yeah, well, you just see parts of the run where it has, say, big, compute or memory.
If you have bursts for memory, what if the application never releases the memory?
We have out of memory killer.
Okay.
Well, first of all, we have the reclaiming mechanism in the kernel. So we have the RAM and swap, and if all the RAM is exhausted, we put some memory into swap. But we don't do the real swap, we do virtual swap. This is the idea. We put some of the pages out to the swap cache, and we slow down the container so it feels like it's swapping in and out, but in fact it doesn't, so no unnecessary I/O, but full field swapping. And once the swap is over, we do some reclamation. That basically means dropping some caches when we can, dropping the, swapping out, dropping the for example, executable pages from memory, since we can reread them back from the files. And finally, if nothing else works, we have auto memory killer as a tool of last resort. But I mean, yeah, what we try to do is to have the system that is flexible enough, but will not allow abuse of resources.
Yes.
So this is a general idea, and this is very, very hard to achieve.
Well, like for the CPU, a burst, like a token-based burst.
Well, the
makes a lot
CPU
of
is a
sense.
different thing. For I/O, we pretty much did that already. So we have I/O limit and IOPS limits, and those, with that help of the user space daemon, we're in the I/O limits. They are already burstable. So for the first few seconds, we allow triple the limit, triple the bandwidth, the I/O bandwidth. And then it goes back to normal. And I mean, no one gets hurt, unlike in terms of memory. So memory is most complicated. And the other complicated thing about memory, and this is what we are working on right now, and I haven't told about it, is that there's user memory, which is pretty simple, and then there is kernel memory that the kernel allocates itself on behalf of those processes. For network buffers, for, I don't know, its own structures about those processes and so on. And that kernel memory, ideally, we need to track it as well. And this is what we do in OpenVZ, but not in upstream. So what we're trying to bring is kernel memory controller, and it's pretty complicated thing, so that containers cannot abuse the kernel memory, because they can do that indirectly, but they still can. And we've also found out that the kernel memory limiter, which we have in OpenVZ, saves us from some of the security attacks in the past, because they are based on the thrashing the kernel memory. Oh, yeah, I mean, there are a lot of things that I wasn't able to talk about due to time constraints. Any other questions? Yep.
Just wanted to say thank you for releasing the stuff today and picking LinuxFest Northwest to announce it. I know a lot of people have been waiting. And that's just a comment, no question.
Thank you. Thank you so much.